Again, welcome and thank you for joining us tonight as the Kubernetes Australia Meetup here in Google's head office today. Very warm welcome to all of you, whether this is your second, third, or very first time. So, as part of Kubernetes Australia, we're really proud to be able to host all of these in-person events and grown so quickly as a community over this past few months. So as mentioned, this is only our third in-person event, and we had so many people who RSVP'd, and thank you again for joining us today, whether you are online or watching this as a recording later. First of all, I'd just like to express acknowledgement of country. On behalf of Kubernetes Australia, we respectively acknowledge the traditional land of Kulkarni Nation on which we are gathered and pay respects to elders past, present, and emerging. So the agenda for today, I'll quickly go through the introduction, and the first topic we have will be presented by our Kubernetes Global and of course Australia organizer on GKE Valera Automation. Second will be on GitHub and Scaffold by one of our volunteers, Prasanna. And third one on DevSecOps or Kubernetes 101 by another one of our volunteers and sponsors for tonight, Sean. And finally, we will have a raffle. And if time permits, we'll have open mic and networking as well as Q&A. So for the raffle, it will be a Google form filler, and we have many swags available from different sponsors, including the Cloud Native Computing Foundation. And if you are not aware already, or if you are on our meetup, you might have seen, we recently launched not our first, second, but third Kubernetes group. And now we have officially become a global organization with the launch of K8SUG Canada. So this is quite exciting. And here we invite you to check out all of our 3 existing and more to come, hopefully, Kubernetes groups. And here are the QR codes. Feel free, this will direct you to our meetup pages. And we also just launched a LinkedIn, which is encompasses all of our existing groups, where we'll post events, upcoming, and yeah, hopefully keep you all updated. So please invite all your friends and join us, whether online or in person where possible. We will be uploading as many of the meetups as possible. So that'll all be available, as well as all of the PDFs, the PowerPoints from each of the presentations. So our mission from Kubernetes Australia and globally is that we're very passionate about the technology surrounding Kubernetes and to hope to accelerate Kubernetes adoption. We are learning from each other and sharing the best practices, and this was at the beginning of our creation just last year. Very warm thank you to all of our main sponsors, including CNCF, Google Cloud, which we are gathered here tonight at the venue, CloudCasa by K8SUG, and JFrog for the continued support. And of course, thank you to our event sponsor, including tonight's Google, and also Nullify, on which we have a speaker tonight. Thank you dearly to all our organizers, including Susan, Prasanna, who will also be speaking, and Harrison as well. So you might have seen them when you first approached us on the ground level. And yes, as always, we are always welcoming more volunteers, sponsors, and speakers. So please feel free to reach out to us anytime, preferably tonight if you have time to stick around and talk to any of us organizers. And with that, I'll hand you over to our first topic and also Thai Kubernetes Australia organizer, Yongkang.
Thanks, Lisa. Good evening, everyone. So today we have a few very exciting topics. So I will do the first one. Actually, that's not my initial intention to do the talking. So I'm primarily organizing. I'm looking for volunteers, looking for more speakers, more sponsors to help us to continuously to run the Kubernetes meetup. So just a little bit of background information. I started the Kubernetes meetup in Singapore first. That's about 9 months ago. So 9 months, we continuously grow 200 members every month. So far, our Singapore division, I would say, we got 1,800 members. So Australia, we only started April. So by now we're already 400 members. So we are growing very fast. It's not because of me or my organizing team, it's mainly the market. Everybody is moving to Kubernetes. Everybody is passionate about Kubernetes. They want to learn. Okay. Again, thanks for joining us. And I hope all the session will be useful to you guys. So as I say, we'll welcome more volunteers, more speakers, more sponsors. So my first topic is about the GKE cluster automation and also Valaro automation. So have you guys heard of the GKE? Anyone don't know what GKE stands for? Everybody knows. Anyway, GKE stands for Google Kubernetes Engine. That's one of the most popular managed Kubernetes. So when customer deploy Kubernetes, they build the Kubernetes cluster. Basically, you got the two ways. You can either build it yourself, or you just leverage the cloud providers. They have the self-managed Kubernetes. Google has one of the most popular one. So not to mention Kubernetes was invented by Google, was originated from Google, then donated to CNCF, become an open source project. Okay, so let me jump to my first topic. So why I'm switching the slides, any questions? Is this something you guys are interested? Okay, here we go. Myself, so I love to be an ambassador. So I'm a CNCF ambassador, and also Calico and CloudCasa ambassador. Also, I'm also multiple organizer. I organize the Kubernetes Meetup. So at Singapore, I also co-organizing the AWS security meetup, also helping AWS meetup as well. Okay, I actually just got a new job last month. I just joined with from 1st of May. I don't know how many of you hold of the company. So basically it's a security company. Okay. So let me get started. So today, I really want to cover these topics. So it's not about the Kubernetes 101 or Docker 101. My focus is everybody should have some hands-on experiences. How to create a cluster, how to deploy applications, things like that. You only need like a few more minutes. So that's why I created the automation. So I created the automation, make it publicly available from a GitHub page. So you just give it a try. So in my session, I will just walk you through how to do it. And how to protect the containers. So remember, even your application, your database running inside of the containers, you still need to back them up. But how to do it? So I will talk about how to automate the protection or backup for your Kubernetes containers. And also, I will list a few resources. If anyone interested to learn Kubernetes or trying to get certified, so I listed a few resources. And obviously, any questions, feel free to interrupt to ask. This is me. I just show off my digital badges. I love Google Cloud. You see, I'm wearing the Google Cloud. That's part of my security certification. So far, I did 6 times Google Cloud certifications. I mean, 6 badges. I actually already did like a 10 times exams already. Because 4 of them I already just recently did the renewal. Okay, I love Kubernetes. So I did all 4 Kubernetes certifications right now. So towards the end, I will share you some resources where you can learn to get certified. So back to the topic, how I can quickly to spin up a GKE cluster. So that's the very popular managed Kubernetes. Not to mention, when you want to go to the latest version, right now 1.27. So Google Cloud is always the first to announce the support for the latest version. The next version will be 1.28. So once it's announced, you will see some other cloud providers. It takes some time before they can make it available. Google make it very clear within 4 weeks. As long as Kubernetes upstream is available, we will make it available. By the way, I don't work for Google, but I love Google Cloud. I love GKE, okay? So how to spin up a GKE cluster? So before you can, if you don't have an account, I also create a video. Basically, you just need 5 minutes. You can sign up a trial account. And once you have the account ready, you just run a few command line. Literally just one main command, you can spin up the GKE cluster. So how to do it? You clone the repository from my GitHub page, and then you can customize, or optionally to customize the cluster name or the machine type or region zone, but you don't have to. And once you have these ready, you literally just run one command. This is the one command. Does that work? Oh, it doesn't work this way. Okay. So the one command is GKE-deploy. So with this magic command, we basically launch a GKE cluster and then deploy a PostgreSQL sample database to the GKE cluster, running as a containers. So all of these typically about 5 or 6 minutes. So with that, let me just log into the console to show you how it works. So any questions? All good? So what I'm going to do is I log in into the Google Cloud. You just open up the Cloud Shell. And then if you are not sure, you can go to the GitHub page. And from here, the first one, GKE Cluster. So can you guys see it? Make it bigger. So what we need to do is you can go straight to the README section. So how to create a trial account, and then you just clone the repository, you copy the command, and then from all the command you paste it here. But I already did, it will give you the warning, since I already did. And now the second step is you can, if you haven't enabled the GKE API, so you need to enable the GKE API. So I already did all of this. So literally all we need to do is just run this one command, GKE-deploy. So I'm going to run the command. So in about 5 or 6 minutes, we will have a up running, fully ready 1.27 GKE cluster. So any questions here so far? Can you guys do it? Yeah, easy. I already showed you, you can sign up a trial account 5 minutes, and you get a 90 days trial, which is also completely different than other cloud. So if you guys are aware other cloud, you will see other cloud typically 13 days trial. But Google Cloud give you 3 months trial, 90 days trial, and then give you I believe it's $300. So you can try a lot of different services. So I just use the Google Cloud to show you how to spin up a GKE cluster. About 5 or 6 minutes, it should be up running. So if you know other questions, let me continue. You are using your own account or company account, you don't want to keep charged by Google. So if you just want to testing, so remember after you've done your testing, you run the destroy. So we will clean up the whole environment. So you're not going to be charged by Google. There is no point. You're doing the testing just for a few hours, you keep running 24/7. Okay. So I also included a few links here. So how to sign up a trial account, the automation code. And if you want to follow Google documentation, here is the links. You can follow the GKE, how to create a GKE. But if you really want to try to create it from a UI, it's just a little bit, it's not that complex, but just more clicks. You need to make a selection, which one you want to do. But from the command line, you just run one command, it's ready in a few minutes. So now the question is, so my day one task is so simple. I just run one command with the automation or could be you are using Terraform or other automation tool, it is doable as well. But I just simply use the gcloud command to create the cluster. So my day two, day one is easy. Few minutes, you can create a cluster. But day two, that's the backup, how to back up the containers, how to secure my containers, how to migrate the containers. Why I need to migrate? You want to move to the cloud. How I move from my own premises to the cloud, or could be you want to move from one cloud to the other cloud. So these are the tools, the day two challenge. It could be data management, could be security related challenges. I do have a few other videos also recorded to show you how to make that happen. So just to summarize, I believe we have 5 minutes yet. So let's wait the cluster up running. So for this section, I just mainly to demonstrate to you how to create the GKE cluster. So again, GKE is one of the very popular managed Kubernetes. So you only need 5 to 6 minutes. You can create a GKE cluster, and it doesn't cost you anything, especially for learning. Okay. And all the automation code also available free at GitHub. So let me check if the cluster is ready yet. Nope, not ready yet. Any question? The next topic, once the cluster is ready, how to enable the backup for the GKE cluster. So well, this is pretty cool. I love it. I only need 1 minute to enable the container backup. Think about it. And it is based on open source. Remember, Kubernetes is an open source tool, open source project. So a lot of companies I noticed they do have the open source first strategy. They want to adopt as many open source tools as possible. So when it comes to backup, the same thing, how to use the open source tool to back up my containers. This is also part of my automation, my interest. I created the automation to enable the container backups. So you only need like 1 minute. But first of all, why we need to back up the containers? The data is the end user's responsibility, even running in the cloud. Because of the shared responsibility, the data is end user's responsibility. If the data lost, the cloud provider doesn't care. Why you are not taking backup by yourself? So that's why even running containers, you also need to back them up. So it could be there is accident deletion or malicious attack, cyber attack, or whatever. All of these things are happening. So what are the common tools? So I listed here a few common tools. Has anyone tried any one of the tools listed here? Backup for GKE. So especially if you are Google Cloud user, you probably are aware of the backup for GKE. That's also something new. It's Google's 1.0 product. But remember, there is no other cloud provider has the native backup tool, only at a Google Cloud. Okay, so but for sure, it's their first initial product. Maybe there are some features are not available yet, but continuously Google will continue to optimize the tool. The second tool I listed here is Valero. It was backed by VMware. It's the #1 free open source backup tool. I don't know if anyone aware of the tool, but basically for customers, they're running Kubernetes, they are doing the backup. Most likely they are using Valero. So it's a very powerful tool. And there is also another tool called CloudCasa. It's one of the best backup as a service, Kubernetes backup as a service. So when you think about the backup, one thing is you can do your backup by yourself. You can install the software, you backup by yourself, you configure the storage, etc. But the same thing like customers, why choose the managed Kubernetes? Because they want the simplicity, easy to do the job. The same thing for the backup. If there is a nice tool help you to manage the Kubernetes backup, why you need to do the backup by yourself, do the self-managed backup? So I will use the Valero, the open source tool, as an example to show you how it works. So how to enable the GKE container backup use Valaro? So you download and install the tool. It's a command line tool, and you set up a Google Cloud storage bucket. And then obviously you need to configure the permission to allow Valaro to access the storage bucket. And after that, the last step is you install and start Valaro. That's it. How to back them up? You run one command, Valaro backup. How to do the restore? Valaro restore. Okay, but it depends. If you like the command line, if you like the command line and you don't want to pay, that's the number one option for the backup. But even the steps I listed here, 4 steps, but for someone not very familiar, it might still very challenging. How do I configure the permissions? How to set up a Google Cloud storage bucket? How to do all of this? So I make it easy. So I make it open source. I create the automation scripts in the same GitHub repository. So that you probably already, from our last step, we already cloned the repository. So all we need to do is just run the Valaro -deploy. So we will enable the container backup for the Google GKE cluster. And once, if you want to clean up, there is another command, Valaro -destroy. So by now we should have the cluster up running. Let's see. Yeah. Can you guys see it? So this time it take 6 minutes, 1 second. If I do a list, actually, let me copy the command, might be easier. So if I do a get nodes, you can see, so how many nodes I have. I just, I purposely only created one node cluster. Did you guys see it's running 1.27? And they created about 4 minutes ago. And if I want to do, you want to see what's inside. So you can do another command, which I deploy the sample database here. I do have a PostgreSQL database running as well. So the thing is, I created the cluster here, but it doesn't mean you can't use the UI. So last time I was demonstrating the feature, and then people ask me, can I still use the UI? Of course. So once you create the cluster from the Google navigation menu here, you can still go to the Kubernetes engine cluster. You can see the new cluster was created here. So if you like to use the UI to manage, to monitor, you can still do it. But the thing is, you don't want to waste time to click here, click there to spin up the cluster. Okay. So if no other questions, I will continue to the next part. So we already have the cluster running. Now, how to enable the, as I say, we just run the one command, Valaro -deploy. So let's run this command now. I'm going to run this command. So while we're running this command, any questions, feel free to ask. So behind of the scene, I automated these steps. I download the tool Valaro, and I created the Google Cloud Storage, configure the permissions, and then run the backup. I also schedule the backup jobs to run every hour. So that's all part of the automation. So just 1 minute, you will see the backup is all good. No question, I was surprised. Yeah, go ahead. Yeah, that's a very good question. The question is, what do we actually back up? So literally, we back up everything you're running from that particular sample database. So it can be by namespace. So right now, I configured to just back up the Yongkang-PostgreSQL namespace. So everything inside that namespace to support your application, your configure maps, your all secrets, your PVC, your deployment or state of sets, all of these will be backed up. So think about it in the disaster situation, everything is gone. How I can recover it? Yeah. So talk about that 45 seconds. Yeah, the container backup has been enabled. And if you want to monitor, we do have a few commands. I will show you in the slide deck shortly. So a few commands, Valero get backup. So you can see my backup job actually also completed. But anyway, I just use a small database. It's 1 GB, the PVC, the persistent volume. So now what we can do is I can simulate a disaster. So I can completely destroy the namespace. And then let's see how to recover them. So I'm going to run the command to destroy the whole namespace. So paste the command here. I don't know, can you guys see from the back? Let me make the slide a little bigger. So I just run the command to delete the whole namespace. And once confirmed, so I can verify to see if the namespace is gone. Yeah, it looks like it's gone. So now I can run another command. So basically it's, no, I didn't copy here. Give me 1 second. So basically it's just one Valero. Valero restore command. So you can complete the restore. So if I do the Valero restore from the backup, which I just did, so it will restore to the original namespace. So right now, based on the selection. So what you can do is you can monitor. If you run this command to monitor, you can see, yeah, only about a few seconds, minute. So the namespace has been created. Now we're going to initialize the containers. So that's about the backup and restore for the container. So the same tool, since it's an open source tool, not only support Google Cloud GKE cluster, it supports literally any Kubernetes cluster, whatever you're running on premises or running from any other cloud. But my automation I created here is I haven't tested on other cloud. Okay, so this command I tested only for Google Cloud, but this command line tool is actually similar. Okay, while we're talking here, 34 seconds, you can see my PostgreSQL database already come back. Any question?
Are we using any daemon set in basically while you basically run that daemon set in the cluster?
It's
the job.
Yep. That's a good question. Though the question is, are we running as a daemon set or just as a normal container? It is actually running as a normal container. So yeah, you can see there is a Valero namespace here. So the Valero, it's running from all the Valero namespace. Okay. Another question?
So does it take full backup or does it take incremental backup when we run it periodically?
Oh, that's a very good question. Yeah, seriously, that's a common question people ask. So the short answer is it is depends on the storage providers. Depends on if you are using the CSI driver, container storage interface. If you are using CSI driver, most of the latest one, they always support increment. So you ended up when you do the snapshot, you always increment. But if there is the storage you are using very old, it doesn't support the increment, it will be full. Yeah. Okay. Oh, why it wasn't showing there? Sorry, what's happening? Let me reconnect. Hopefully it will be back. Yeah, looks like it's back. Could be good. Sorry, any other questions? So basically, so far, I only talk about the, oh no, not this one. So what we did here is we already simulated the disaster. And we removed the namespace, we restored the namespace. Only like a few minutes you can see, not only we enabled the backup, we also did complete the backup, we also restored the namespace. So in a container world, it does move fast, right? And I also including a few command here. If you want to know how to list the backups, how to do the restore, how to check the restore logs, and some other additional commands. What are the typical use case? So earlier we talked about why you need a backup. What are the typical use cases? It's mainly for the backup DR or application mobility use case. You might want to say before you change, you want to take a whole backup. Or maybe you want to move from a production side to the DR side. You want to move from on-premise to the cloud, or maybe you don't like the cloud, you want to move back. So all of these are supported, yeah. And the other cool use case is about a simplified upgrade maintenance. I haven't touched on this one yet. So I don't know which version. Most of the customers, they actually, in the Kubernetes world, they always keeps upgrading to the latest one, because every 4 months you got a new version, and only keep the latest versions, latest 3 versions. You have to do the upgrade very often. But to simplify, how you can use the tool to simplify the upgrade. Instead, we do the upgrade from a 1.20, let's say 23, you want to do 1.27. Most likely, there are a lot of the challenges. Some of the stuff will stop working. The reason is from 1.24 to 1.27, a lot of API changes, and some of the API are already deprecated. Your YAML file works perfectly for the 1.24, but doesn't work for 1.27. So if you do the in-place upgrade, you will see a lot of surprises. So by doing the backup from an older version, 1.24, and then I restore to the 1.27, life is a lot easier. And you can validate, once you validate everything is good, you can switch to the new version. Does that make sense? So why Valero for the GKE? It's a #1 free open source tool. Why not? If you don't want to pay, if you love to use the open source tool, and it has been trusted by many customers globally, and it does cover the major use case like a backup DR migration. It is relatively mature, but it's a very good fit for the skilled technical user. If you don't like a command line, I never use the command line, I never use the Linux tool, so that would be challenging. So if that's the case, that's why I put here another. I was asking, do I really need a third-party tools? There are multiple vendors also doing the Kubernetes backup. So what are the value add on top of the Valero? So you can see in a short, as you can see, the Valero, it's a fully command line. You don't have the nice UI. If you don't have the skilled person, it might be hard to operate. And there is a lack of the multi-class management or multi-cloud management. Sorry. Yeah, we are using the Zoom to recording. It looks like the screen share wasn't, it disappeared somehow. Give me 1 second. Oh, yes. Yeah, it's back. Lack of the multi-class management, multi-cloud management. What about the recover? Do you know what's recover? The question that the guy asked earlier, what's backup? What do I recover? You don't have such visibility from the nice UI to give you the details. This is a PV I restored, I backed up, or this is a configure map or secrets I backed up. So there are some other tools like CloudCasa actually does provide it. You don't have to change anything. You continue to use the #1 free open source tool. But on top of that, CloudCasa give you the nice UI. So give you the multi-class management, advanced recovery, guided recovery, makes life a lot easier. Even the backup job, which I did right now, all the schedules I configure right now, it will be displayed from the nice UI. So that's the great advantage on top of the free open source tool. Question? If you guys are in the back, you don't want to stand, you can sit properly in the stairs. Okay, I just including a few more reference links. Feel free to take a note, and I will share you the slide deck anyway. Anyone wants to learn Valero, or you want to give it a try? So remember from the beginning, I already showed you how to create a Google Cloud Trial Account, and how to create a GKE Cluster, and enable the Valero backup. So 5 minutes, trial account, 5 minutes, 6 minutes, the GKE Cluster. 1 minute to enable the Valero backup. You got $50. Okay, you only take like 15 minutes. So if you want to, yeah, technically that's sponsored by CloudCasa. If you want to just do it, give it a try, they will send you a $50 USD gift card. That's for this section. So basically, we talk about there are many different tools for the containers. So why, how, what are the typical use case? Why you should go Valero, and why you should go manage backup. You don't want to manage Kubernetes. Why you manage the backup? So when it comes to Kubernetes, it makes a lot of sense to manage the Kubernetes backup, and plus you manage the Kubernetes. But really, I'd love to highlight, if you don't want to use any third party, just go with Google Cloud. They got a backup for GKE, the native tool. So give it a try. But it does take more time. Yeah, just to be honest, I did try. It took me about 30 minutes to enable the backup for GKE. So you see, for the open source, only like 1 minute to enable. I'm not saying Google is not good. Google actually is one of the best. There is no other cloud provider have the native backup tool for containers right now, only Google. Yeah. So just including a few links. So anyone want to get certified? I did 4 of the Kubernetes certification. So these are just including a few links. So based on my experience, I did the 4, or use all different tools, different materials. But I realized comparing all of these, the Udemy or the Code Cloud, you buy from Udemy is cheaper. Same training from a Code Cloud, but it's a lot cheaper. You got a 1 year subscription. So typically, when I was doing the CKAD, actually it cost me 16 Sing dollar. It's a pretty good deal. And not to mention, there is a simulator provided by Killer Shell. So before you go to the exam, you can use the simulator. It's very much similar to the actual exam. So you can get to some actual feeling how the exam looks like. It's complete, especially for the CKA, CKAD, or CKS, it's completely hands-on. It's not the multi-questions like the typical cloud providers. So that makes it slightly a little bit hard if you're not a hands-on person. But having said that, anyone is certified. CK, okay, that's good. Do you want a sticker, the Kubernetes sticker? Yeah, do you want to go to KubeCon? Yeah, the next one is in Shanghai, yeah, September. The first time I went to the KubeCon is April. April, I went to Europe. I joined the KubeCon in Amsterdam. It's amazing, like 11,000 people on site. It's a huge event. So lots of learning for me. So I do encourage people, if you are, just join the KubeCon event. Definitely you won't regret. I think that's all from my side. So any, yeah, go ahead if you have questions. Yeah.
I read you were showing us the list of options for backing up the cluster. There, in one of the points were written, and ATC did not define it.
Yeah.
Just wanted to know why is that so?
So this page. Yeah. Okay. So in the older days, there is no nice backup tool like a Valero, like a CloudCasa or any other tool. So the only way you back up the Kubernetes is do the command line ET. So the tool, it does the job, back up the whole cluster. But you are not able to do like every 10 minutes, every 20 minutes do the backup. So you can't do very often the backups. That means when you are doing the restore, you basically, for example, you probably restore from 4 hours of good data, and then you overwrite everything. So that's why it's not really a perfect tool for the container backups. So within the 4 hours or few hours, lots of changes. You don't want to lose the 4 hours data and or go back to roll back to like a 4 hours ago. So not to mention it's a little bit more challenging to do the recover. So especially when you move from one cluster to the other cluster or from one cloud to the other cloud, that makes it even harder. So literally, why you need to back up the whole cluster? To me, there is no point to back up the whole cluster. When it's gone, it's died, I just spin up a new cluster 5 minutes, 6 minutes. All you care is the application. If I'm an application, my data is gone, that's the problems. So that's why the tool from a Valero or other commotion tool, just back up your application, back up your data. When you need it, I recover your data, which is more faster, more efficient. Comparing to the etcd tool provided by Kubernetes, it does the job, but it's not that great. Does that make sense? Cool. Any other questions? If no other questions, we will move to the second topic. Prasanna, yeah, come here.
And sorry about that, but it's a quick introduction about myself. I'm currently obviously organizing and helping out with the introductions here at Kubernetes. So previously, I was also teaching with Kubernetes People, which is our very first group, by overseeing the online versions of our Zoom and also keeping an eye on the chat and all that. So I'm based here in Melbourne. I'm currently studying Commerce and Computer Science at Monash University. So yeah, it's my position to help out with this. And with that, I think I'll pass on to Shantanu for our second topic of the night. Thank you.
Thanks. Thanks, Luisa. Good evening, everybody. So, okay. So I guess many of you know the scaffold. Anybody knows? Wow, cool. So I'm not alone here. That's great. So the scaffold is basically, it is kind of a gift from Google, and I really love that. The important thing about the scaffold is like it is the speeding up of the entire development cycle by many folds. If those who are using scaffold, they know it very well that how it is less basically. So without the scaffold, usually how does the development like looks like? Is it's pretty much it's $1 million question. Like we have to simulate that whole environmental setup in your local environment, and then service integrations, and then it's all on top of all. It adds lots of like the lesser productivity, lesser speed, lose the focus, and many more. Those challenges are easily addressed with the help of the scaffold. So what does the scaffold do usually when we use in our day-to-day development activities? Let's say I have a YAML file and I have a source code, and I want to change it now. So without the scaffold, I will have to do this code push and some DevOps pipeline will be there. And that DevOps pipeline builds the code and creates a container registry. And then someone has to like GitOps kind of a thing or some other way. They have to deploy the Helm charts or any chart like customize. There are many options to deploy the things. And then they have to put the container registry and then deploy into the Kubernetes cluster. This is a tedious task, and trust me, nobody wants to do it as a developer, or it's kind of like a distraction, a lot of distractions. So this is the pain point, and this is what exactly addressed by the scaffold. So let me just show a demo exactly what happens here. So here, I have a website wherein rocket is literally crashing through land. So now let's run it safely and just by change of the code. So it started deploying and it deployed. I just changed the code, it did the job for me. I didn't have to do anything. And now if I refresh my page, yes, it started to launch. So much of it is reduced just by saving the button. Looks cool, isn't it? So how many of you are here Kubernetes developers? Okay, cool. There are. So at least one guy or two guys are here. They're not using scaffold for sure. I know. So if I know this is not anybody's fault. It is basically the Kubernetes. Its whole ecosystem is so big, so vast. It's too difficult to evaluate what is right for us. We have to have really great experts in the team, and they should guide us. They will have to guide us, or we have to evolve by ourselves, or with the team efforts, we have to invest lots of time and iterations to understand what's needed for us. To do all these things and to figure it out what's right for us, it takes a lot. It takes ages. It's every guy Kubernetes when he or she starts the journey, he starts from scratch. There is no something like, okay, I will just start from like something. And it's quite hard also to understand the Kubernetes from middle. It has to become, you need to know the most of the resources to use it most efficiently. That's when you start to think, okay, what I need, and is there any plugin available in the market to address my need? Okay, so this is the beauty of the Kubernetes scaffold. Sorry. Okay. So one of the pain points, as I said, like without scaffolding, it's about the environmental shift. Like I'm working today for Horfix on some branch. Now I want to shift to some other branch or some other environment. So what happens here? Like typically without scaffolding, I have to iterate through all the configuration steps, and I have to produce all those things in my local environment, and then I have to run it. It's a painstaking point, really. Nobody wants to, and if that whole thing is like in some, let's say in some different clusters, it's a painstaking to some like highest level of any, and developers do not want to do that. Basically, it's kind of like most of their time spent on that kind of stuff. So here with that, the profile is a savior from the scaffold. It saves you a lot of time. So what happens with the profile here is like you just have to point to the context of any Kubernetes developments clusters in your YAML file. That is scaffolds has a YAML, and you can switch it over. Like when you want to run it, you just mention which profile you want to run against your code. In this case, I have a profile called GCP, and I am pointing to a GCP cluster. And when I run the scaffold file, when I run the code, it just goes and deploys to the scaffold. And that's all we do. It's a clear separation of concerns, and no cross-cutting concerns are comes in the development activities, saves a lots of time. And we can add any number of profiles, be it in a bare metal server or any cluster or any just like that. So okay. Yeah. So where do we find the best tools and best tools for Kubernetes? The open ecosystem. It is basically CNCF is the best place to look for. Lots of brilliant and talented minds. They have come together to form a CNCF foundation, wherein most of the efficient use cases, efficiently handled and solved in this, and they have been put up here, and they are all free. And being a Kubernetes enthusiast, this is the place where you have to spend most of your time to find out what are the offerings there in CNCF Foundation, and is it to solve my problem? And that's it. Yeah, that's so any questions there? Yeah.
Can you hear me from here?
Yeah, I'm able to hear you.
Okay.
So you,
I'm concerned about the scaffold. So what does it do? What does it do? Because I think I missed it somewhere. What does the scaffold do?
so the scaffold is a kind of build and deployment aid. It does the automation of the build and deployment in your local machine. You can also use for the real production use case, but it's not used in most of the places. So when you change a code, typically the development lifecycle involves build that code in a container registry and push into the container registry, and then you deploy a Helm chart or a manifest, Kubernetes manifest file, and which pulls the container registry and the container and deploys to the Kubernetes cluster. That is either done through if it is in a local development, you might choose many different ways. Otherwise, it can be done also through like some Java pipeline, right? This whole thing is addressed by the scaffold, which it does automates for you as soon as you save the code.
Are you trying to say the scaffold automates this process?
Yes.
And what about the GitHub? What about the GitHub tools like Argo CD?
Yes.
Argo CD and Argo CD backup data. So what does it do?
Yes. Yeah. So GitHub or Argo CD is after development is done, and when you push the code to the code repository for higher and upgrading to the higher environment, like could be like test environments, dev environments, or prod or pre-prod UAT or any environments. Those scenarios, it is useful wherein you have already done your portion of development activities, and then next goes to the handover goes to the next dev team or SRE team or release management teams. So it aids them to do the release management activities. But scaffold is for the developers mainly, wherein you can't wait till the GitHub do the job of deployment to some cluster. So you basically, if I have to do some code change and I want to see that reflected in a cluster, I can't like just change some code and then wait for some time to do that whole process kicks in, and then it takes at least some 5 minutes. Totally lose my focus basically. But instead of the scaffolding, it happens right away when you save the file, and it happens quickly because it maintains a kind of a caching, and that caching helps avoids the container build from the starting point. So thereby it's kind of an incremental build. It happens and immediately it deploys to the cluster, and it does the pushes the registry. It takes care of all those scenarios. It usually happens when it passes through the DevOps pipeline.
Sorry, finally, what about when you have an architecture where you have Jenkins and you've got
Um,
Do you still need the scaffold?
Could you, sorry, the voice was not loud.
Okay, what I'm saying is like, if you have an architecture where you have Jenkins, then Jenkins or within Jenkins, set up what we call webhook. In a webhook, triggers when when there's a pull request, webhook alongside Jenkins triggers this you were talking about the continuous integration pipeline. So if you have this architecture in place, do you still need scaffold? That's my question.
Yeah, yes, as I said, like without scaffold, there are many different ways are adopted by these industry folks to mitigate their pain points. Yeah, but the setup is super easy with scaffolding than this whole any other like because this is something the pain point specifically addressed through this solution. This solution is meant to address that problem. But yeah, there is a different ways it is tackled. Yeah, that could be one of the solutions, the one you mentioned.
So this is primarily being used for development environment and not for production, as you say, but does it work with all different kinds of clusters? Like, can I run this as a client cluster, for example, different types of clusters when it comes to moving from development to production? How does that actually work? Is there much work involved with converting a scaffold development environment into a production environment?
Sure, nice question. Yeah. So for the first question, like it works across any cluster. It just Kubernetes cluster, right? It works. And so the second question, like can we use it for production and other environments? It is kind of like not mandatory, but there are couple of best like Cora. One of them, it uses the scaffold for all environments, production, development, testing, everything.
Yeah, I think what I meant more specifically was supposing I've finished developing in my development environment, I'm happy with the state of the application. And then I want to actually move that into a production environment where every single code change I make does not change something in the production environment. Like, I understand that we're making a code change, and it's changing something in my development environment, but that's cool, it happens in Snake. But in a production environment, I might no longer want that to happen, you know what I mean? So I'm just wondering, is there much work in the process of like just taking this from my local machine, running on my kind of cluster or whatever, then moving it into a cloud infrastructure like GCP? Is that difficult to use?
You mean like actually I'm lost with the question, but did you mean so when at the time of the development, yes, that code changes will deploy to the cluster, yes. And at the time of the production, you don't want that situation to be there. Yeah, obviously no. Because that's when you choose to have that what kind of the deployment model you want to follow. For because after development, you push the code to the repositories. So development works on a branch, some branch, and then when you merge when you build the DevOps pipelines, so you can choose to do differently. That time you get that option, that kind of responsibility of delegated to the kind of the software like DevOps software tool use you are using. So basically, scaffold is not used in that DevOps pipelines. Then scaffold is pretty much like I just said, plain text. It doesn't have any like that. So it is totally it's in your totally in that the team's control where the scaffold has to have its life and where it should not be having its life.
You see it as just being mostly local to the dev workstations more than part of the infrastructure work on.
Correct.
When you so you see it as being more as something that's ran mostly on a development laptop, basically.
Yeah, basically on development laptop, and though you are in a development laptop, you can connect to any cluster you want. You just because it's a context, And the context could be important, maybe EKS cluster, GCP cluster, variable cluster, or Azure EKS cluster, any cluster. It's total flexibilities. Yeah. Thank you. Nice question. Yeah. And so having said that, you can also use for the any production environment also, and you can, because scaffold gives the different options of this is a scenario when you run in a development mode, you run it in a watch mode. But if you do not run in a watch mode, then change of files cannot trigger the deployment activities. So that's when you can also go with that you can use that kind of mode in the production and other environment. Because just there is an option for that, but since nobody is promoted, I'm not going to wait for it. So questions?
So just checking. Yeah, just wanted to check with this tool, what kind of other tools could be integrated during the, like if you, as you said, when you make some changes to your code, it might not always be your code directly being turned into a container image, right? Rather, there might be a process behind once you basically save your code and your pipeline will have some process like compiling it into an executable and then pushing it to a particular kind of an image and then creating that final image for deployment, right? So do we have any other tools that could also be integrated like GitLab scan, code scan or something other basically like Sonar scan or some other kind of code scanning that happens on your code before it gets being deployed to the cluster?
Yeah. So this is where the complexities arises. Yeah, that's one of the reasons I said I don't promote for the production or any other environment. Because yes, the security DevSecOps comes all the kind of like before the actual promotion happens to any higher environments, all the code scanning and many unit testing, so many things takes care of that. So that point in time, the scaffold is not really is not a player in that area. But when the local development activities, it's a player because it's just happening in the local and there is no surface area of anything. That's a nice question, actually.
Like Argo receiving.
Yeah.
What difference between this and Argo would be like?
Can you?
Sorry, yeah, have you used something like Argo CD? And what would be a difference between?
Argo CD and yeah. Argo CD is as I said, like it is the next stage, like scaffold is when we are developing it in the local this aim, but when it's Argo CD is a GitOps thing. It is once we push the code to the code repository now, and some DevOps pipeline goes and builds the image and pushes it to container registry. And then now you got the Helm chart, and the Helm chart is going to be consumed by the Argo CD. When any changes happens to the Helm chart, so Argo CD triggers the deployment of that the newly deployed Helm artifacts plus the container. So Argo CD is kind of an actual industry like level development tool to the Kubernetes cluster. It is not for at the time of the development in itself. It is like not friendly at the time of the development. It is friendly at the time of the deployments in the rest of the things other than developers.
Thank you.
Did that answer the question? Oh, yeah.
Yeah, you mentioned.
Hold on 1 second.
Yeah.
You mentioned that you can use the scaffold to deploy code changes to the environment. But what if we have some simple application with small database, an application on top, and I have my DDL script that describes my table. So, for example, I want to add one more column and then to add some code that protects that column, and it's helpful. Like create that
Table.
my database. Yeah.
This is the nice version. The kind of like the problem here in this tries to solve is totally a kind of like a different side of the spectrum. The database thing is something still is a one-time activity, like adding the scaffold utterly fails because first thing is that scaffold gets its life only has its the scope. The scaffold has the scope only to deploy a Helm chart and containers to the things, and it does not do the internal of what these things do. So if anything like database, they are one-time activities things. Scaffold and scaffold is not something fit for that. That's a nice question.
Thank you.
Any questions? All right, then I will hand it over back to Yongkang. Yeah.
Thanks, Prasanna.
So just get started, Bhat and Shantanu. Topic for that, so we have Shantanu from Nullify, who's responsible for that, and it's for Thank you.
Cool, thanks. Everyone, I'm Shantanu, the co-founder and CEO of Nullify. I apologize, I'm visiting from Sydney, so we left our banner and our swag back in Sydney, but I just want to start by thanking Kubernetes Australia and obviously people for hosting us and Yongkang giving me the opportunity to do that. Today I'm going to be talking about building secure node Kubernetes. So how do you secure everything you're building and running without slowing down? And some of the challenges and experiences I've had scaling DevSecOps on managed Kubernetes. So I guess maybe just quick show of hands, like who is actually building on Kubernetes day to day. Yeah, cool. And is that like on GCP or AWS or maybe OpenShift? Sorry if you lost. Cool. So everyone's, some people are on Kubernetes. So I guess a bit about me. I'm a software engineer, or I was a software engineer. Started building things on the cloud. Probably when I started working at Cisco as a software engineer, doing a lot of stuff with Terraform and Ansible. Started doing more and more cloud and DevOps engineering. Eventually going a lot more towards AWS and cloud security. So lecturing cloud security at the University of New South Wales, and then working with enterprise cloud customers, specifically around scaling cloud security and DevSecOps. And if this talk sounds familiar and you've been at Cloud Security Conference last year or DevSecCon last year, that's because it is. It's the talk I came up with about 7 or 8 months ago. And I came up with it because whenever I was talking to customers who maybe they just started on their container journey or they just migrated to Kubernetes, there was kind of this gap in understanding between their existing security testing practices and then how do they sort of uplift that to building on Kubernetes. So that was kind of the motivation behind this, is whenever I was talking to teams that were running or trying to run fast in the cloud, they were just unsure about how to get started. And it was kind of like a bit like boiling the ocean. So how do we even get started with, what are the issues, what are the threat surfaces, and what type of controls do I need to implement to make sure I'm building securely without slowing down? Since then, I also founded Nullify, which is a cybersecurity AI startup. We're a venture-backed startup working with everything from startups all the way to enterprise. So helping bridge the gap between developers and security teams building natively on the cloud. So a lot of my experiences from working at big tech or in cloud consulting really paved the way for some of the ideas and processes we wanted to build into an automated product, an automated SaaS product. So again, thank the sponsors and thanks Kubernetes Australia. So who's actually heard about shifting left? And we start from the beginning. Anyone heard about DevSecOps or shifting security left? Yeah, quick show of hands, cool. So obviously it's been around for some time. The idea is that you embed security testing processes earlier into the pipeline, so you're not slowed down whenever you want to deploy to production by manual security testing processes. And oftentimes, if you do this correctly, you get advantages in not just speed and security, but also cost, because you're less reliant on human resources, pen tests, and things that actually cost a lot of money. And ultimately, what you get is less vulnerabilities in production, which means when it's time to fix things, you're actually fixing them in staging or developer environments, and you're not actually spending on fixing them after they've already been deployed to production. And so this is good, or it's pretty decent. As I said, it's been around for some time, but this kind of philosophy or this practice of DevSecOps still has persistent gaps into how modern cloud native teams are running. So many of you building on Kubernetes probably know you have the developers on one side, they're writing this application code, probably throwing it over the fence into the pipeline to the platform and cloud ops teams. And then somewhere in their application security or the cybersecurity teams are trying to police everyone and really just slowing everyone down. There's a lack of context and governance across these sort of three silos. And ultimately, even though engineering environments are the new attack surface, so whether it's vulnerabilities in your packages or hard-coded secrets, these security testing practices are still remaining very, very siloed. And obviously the result of this is everything slowing down, getting less secure, and costing you more to deploy to production, which if you're a software company is a disaster. And so everyone obviously knows as well that everything is code, everything is an API, whether you're a software engineer or a cloud engineer, you're writing Terraform, you're writing your manifest files and your Kubernetes manifest files. There's about one security engineer for every 100 or 1,000 developers sometimes. If you talk to a bank, they'll have almost 1,000 developers for every security engineer. And so this builders to security ratio disparity makes it very, very hard to scale cloud native security. And whilst this isn't sort of a unique or a new problem, I think the best way to observe this in the wild is looking at how containerized environments and workloads are being secured. So containers really change the application security model. You're not deploying, you're not manually deploying things. You're rebuilding, retesting, and rebaking containers from third-party base images every single time you deploy. And you're usually doing this in automated pipelines, or you have a GitOps workflow set up where every time you push a change, it's getting deployed to production. And because of the nature of these workloads, oftentimes they're ephemeral, they require the need to be stateless. These traditional application security testing model doesn't really apply. And so there's a nice quote here that the best way to secure these short-lived and ephemeral workloads is to start their protection as earliest in the SDLC as possible. So as soon as it's instantiated, ideally before it even is pushed to your main branch. And for those of you using Kubernetes, you know how complex and the ceiling of complexity and the pain of maintaining it can be if you're managing very complex workloads. Same way that containers change the application security model, Kubernetes really changes the operational security model. So we're moving away from static IP-based security. All your nodes are dynamic and you're deployed on a managed Kubernetes cluster, maybe using GKE or EKS or whatever cloud you're using. It's all declarative, it's all dynamic, and it's all gated through your APIs. So before, whereas attackers would have to traverse different perimeters, now all they need is access to your Kubernetes API server. I think recently a really high profile attack was, I think it was Tesla or another big company had a Kubernetes API, master API server just exposed to the internet. So you could just trivially enumerate any data or metadata around the Kubernetes control plane. So it requires like this software defined networking sort of model. And because of this, it introduces concepts and object types.
Hi,
is
bus car.
something about this needs to be done through automation.
So yeah, so you know what's going on, right? I need to install Microsoft Intune.
I think someone's talking. We should move that. All good. And so application configurations are deployed and managed in new ways. As I said, you're deploying and managing everything as code, and containers are very opaque, so that they're not very traditional, they're not very well suited to traditional security testing tools. In order to secure this, you really need to have baked-in automation from the start. Does this look scary to anyone? This is a very basic data flow diagram published by the CNCF for a cluster, which is, I think, 3 worker nodes, 1 tenant, so 1 cluster, 3 worker nodes, and a couple of deployments. So I think just 1 deployment. And you can see, despite such a simple workload, there's a lot of trust boundaries, both at the container level, as well as the Kubernetes control plane layer. So it's not a surprise that a lot of security teams these days are struggling to understand or even conceptualize where to begin with embedding security controls into their Kubernetes development workloads, or the development of their Kubernetes workloads, especially when a lot of them are not really familiar with how containerized workloads are being built by their developers. So coming back to those silos I talked about earlier, a lot of security teams these days they're not really connected to how their developers are running, and even less so on Kubernetes. And so there's some interesting stuff happening in this space to help this. You have CIS benchmarks published with good frameworks and reports around which controls you should probably implement. And there's also plenty of threat models and attack frameworks. I think Control Plane and Deciduous are doing cool projects around using GraphViz to create attack trees and visualize attack paths that people can use to exploit your Kubernetes clusters. But ultimately, like, this is still just too hard basket for a lot of different companies, especially if you're a developer or you're a security team just trying to understand where's the low-hanging fruit and where can I start with adding security testing into my processes. So I want to start with just today and just talk like a really, really simple level 1 Kubernetes threat model, and then map this threat model to some basic threat surfaces, and then from there just say what are some simple controls that you can go today with and start implementing in your pipelines or in your development processes. There's actually a slide I stole from Ron Amosa's talk at CloudCasa. He talks about a similar topic, but more just about multi-tenancy. Encourage you, it's a great talk. And one of the things he articulated well, which is the Department of Defense's threat model for Kubernetes, is primarily consistent of 3 main threat actors. So clusters are attacked for obviously data theft, so exfiltrating your proprietary data, maybe your customer data, but they're also attacked for data compute theft. So people hijacking your nodes to mine Bitcoin or stuff like that. And so if you look at the threat services or the threat actors in the scenario, you have your insiders. So it's probably the ones that companies underestimate the most. So your lead platform engineer who has complete admin access, has root access to all your prod cloud accounts. What type of privilege escalation paths could an attack or exploit if that platform engineer's credentials are potentially exploited? You have the obvious ones, bad actors, so people continuously and actively trying to exploit your Kubernetes clusters from the outside in, doing lots of both social engineering as well as external based attacks. And then the one probably I'll be focusing on a little bit is around your supply chain. So everything that you're consuming when you're building your workloads, from the open source libraries and your dependencies, your Docker images and the libraries and dependencies that they pull in, down to the secrets that you might be accidentally hard coding into your container images. So 3 really simple threat actors: insiders, external bad actors, and the supply chain which you're building all of your workloads upon. And so that's a pretty good place to start. But if you were to go home with that and then go on the CNCF landscape, again, that looks pretty scary to me. I'm not really sure. There's so many different tools here. I'm not really sure where to start and which of these tools map to which security testing activities, which of them overlap. Obviously, every vendor these days will tell you that they do everything, but it can be very daunting to get started with some of these testing processes when you're not really understanding how they can fit into your development processes. So let's map those threat actors to some really simple threat services. So Obviously, starting at the very furthest left, you can possibly go. Your Kubernetes cluster is running containers. Those containers are built from some sort of application code. Maybe they're Ruby on Rails applications or Django Flask applications, so they're in Python. And then after you build that into a Docker image, scanning the built Docker images and making sure that you're not pulling in any base images or third-party images that are vulnerable. So securing things at the container level and making sure of things like secrets or hard-coded potential sensitive credentials aren't hard-coded into your container images, which can then be exfiltrated at runtime by attackers. Then at the cluster level, so everything up to the Kubernetes control plane, how do we make sure that your pods aren't running as root, or there's no RBAC controls that are allowing for privilege escalation. A lot of different things you can do just by scanning your Kubernetes manifest files. And then lastly, at the cloud layer, so where is this cluster running? Is it running on GKE? Is it running on EKS or OpenShift? I'm very sorry. Wherever it's running, even if it's bare metal or you self-managed it, there's a lot of complexity in securing the workloads once they've been deployed to the cloud. So making sure that the IAM policies are locked down, making sure you're scanning all the infrastructure as code that deploys and managed clusters. There's not things like open ports or any infrastructure dependent on your cluster, let's say storage buckets that are open to the internet. So let's start with code. What's the easiest thing that you can do when you're trying to secure your code at the application level? Let's say you have an application code monorepo. The goals here are to really integrate into developer workflows and code review processes. That way your developers aren't slowed down whenever they want to deploy to production, and you're failing as fast as early into the SDLC as possible. So a lot of companies, a lot of teams, as I said, small and large, struggle with kind of scaling these processes because they think the limiting reagent is training their developers on secure coding practices. But you find it's a lot easier to just embed the security testing automatically within the pipeline, so developers can get continuous embedded feedback on every pull request they make. So obviously the goal here is to make sure that no potential hard-coded secrets, vulnerable code, or vulnerable packages are merged into the main branch of your application code's repo. Obviously, once it is and it kicks off a pipeline, that application code is then built into a Docker image, and then that Docker image is deployed into your Kubernetes cluster as a container. So how do we make sure that everything defined in code doesn't contain secrets, vulnerabilities in packages, or vulnerabilities in code? The easiest way to do this is embed open source security testing tools into your pipelines. So every time a developer raises a pull request, run different types of tooling on the pull request changes for common weaknesses, and then push code fixes and address these vulnerabilities before it's even merged in. But actually, I want to double click on secret scanning here as well, because a lot of times you see Docker containers and Docker images in runtime, which have like API keys just being hard coded. So make sure that you're using things like parameter store or vault secrets management processes that make sure you're not relying on hard-coded secrets at runtime. So moving up to the container layer, so you've made sure the code running is secure, but now you have to make sure that within your Docker file, your container is not running as root, or your Docker file has any form statements for base images which have vulnerabilities in them. So the goal here is to prevent insecure images from ever reaching your registry. So you may have let some stuff get by from your code repository. It's been merged into main, but now that it's been built and deployed, before it gets deployed to production, pushed to an image registry, how do we make sure that those images are as secure as possible? So securing the build artifacts of your pipelines. The security controls and activities you should undertake here are really good change management processes. So this is not even really a scanning process. It's more just around how do we get really good guarantees around what is running at any given time. And the easiest way to do this is to tag your images with the commit hash of the pull request. So I've seen a lot of teams running with like just version latest, and then something breaks or there's a security vulnerability, and you just have no idea which code change added the breaking change or the security vulnerability. So just really easy way to get around this is tag your Docker images with something unique, ideally the commit hash. But then there's a lot more complexity that comes after this, which is, okay, there's a lot of low-hanging fruit around scanning your base images and then tagging them, but how do I make sure that my third-party images, let's say, or even my own code that I've run and I've scanned statically, doesn't have parts that attackers can exploit to do things like make suspicious callouts or pull in malware from third-party servers. So there's only so much security you can reason about statically before you need to start doing dynamic analysis. Some of the ways you can do this is things like DAST, so dynamic application security testing. I'll talk a little bit more around doing that at the cluster level in the next slide, but doing that for containers can look like running Sysdig Falco on third-party images or Aquatracy, eBPF-based tracing tools, which allow you to monitor the network calls of containers at runtime. It's very important you do this ideally in a staging environment. So maybe you have a cluster or you have two clusters, one's for staging and one's for prod. These tests can potentially, or this analysis can potentially be breaking and also very costly sometimes from a compute perspective. So you probably don't want to do it in production, but make sure you're doing this before you are rolling over to production. Because I've seen a lot of container images that don't have any known vulnerabilities in them, so no CVEs, but they do contain malware or suspicious strings or malicious behavior that can only be detected at runtime. I've got a hand there. I'll just 5 more minutes and we'll take questions after. And then I mentioned image scanning. So use something like Trivi, Gripe, maybe. Again, you can do this at the registry layer, but then you get ECS or whatever container registry or Google Cloud you're using, just thousands of vulnerabilities. So again, going back to shifting left, how do we minimize them as much as possible before they're even led into your image registry to begin with? Next is a cluster. So up until this point, we've secured the application code, we've secured the container runtime, at least, the container definition. But now, how do we worry about, or how do we reason about the security of my actual Kubernetes cluster and all the objects and deployments that I'm managing in there? So a lot of the time, this looks like either a separate repo, which contains all your infrastructure's code, or your Kubernetes manifest files, your Helm charts. Oftentimes there's like a GitOps agent like Argo listening on this repository that updates your cluster every time there's changes merged to main. And your goal here is to stop misconfigured or insecurely configured resources from ever being merged into the main branch of your manifest or IAC repo. And the idea behind this is a lot of the issues that you might find at runtime can be prevented from just statically analyzing or statically scanning your Kubernetes manifest files or Helm charts. So I gave an example earlier around maybe there's containers or deployments or pods in deployments running as root, which shouldn't be. That's a nice easy thing you can detect before you even deploy your new changes. So this looks like IAC, SAST or IAC code scanning. So there's Chekhov, there's Kubescape is a really well-maintained open source tool, which is what we use as well. And you can use this to do things like find common weakness enumerations in your manifest files, as well as starting to look at now, how do we reason about the dynamic security of our clusters? So this is a little bit harder and a lot more complex to automate at scale, but cluster scanning and cluster pen testing. So some great tools out there. I really like KubeBench and KubeHunter. They'll enumerate a bunch of payloads against your Kubernetes API server and tell you whether or not the master API server has any vulnerabilities, whether it's exfiltrating data or all the way up to popping a shell and getting a reverse shell. So this is another thing that in my time with customers, companies aren't really thinking a lot about. They think, oh, it's Kubernetes, it's just secure by design, or whatever cloud provider they're using to manage the hosting of their Kubernetes cluster. They think it's abstracted to them to secure, but because they have a WAF or a load balancer or something. But ultimately it's up to you to make sure that someone somewhere who can get a hold of the actual load balancer or API server endpoint can't exfiltrate data or can't do anything destructive with that. And the best way to do that is run tools like KubeHunter or KubeBench against, again, a staging environment, because some of these tools can be destructive. And there's a lot of open source projects around this. KubeStriker is another good one as well. And then lastly is the actual managed infrastructure layer. So we've gone from the application code that you're building and then to your containers, then your manifest files that you're using to define your Kubernetes control plane. But then where's that actually running in the end? So it might be running on GKE, you might be running on OpenShift or EKS. Ultimately, it's very likely you're defining the infrastructure for that in code as well. So maybe you have a separate repository just for the Terraform or CloudFormation or CDK. And securing this is just as important as securing any of the three previous threat surfaces. The lowest hanging fruit, I suppose, or the least path of resistance for an attacker is, just getting prod access to your data through an open S3 bucket or an endpoint that just is open to the entire internet. The easiest way you can pick up on this before it reaches production is scanning your infrastructure as code. We use TFSec under the hood at Nullify, and there's plenty of other great open source tools you can use to secure everything from Terraform to CDK or Pulumi. Whatever infrastructure as code you're using, make sure you're scanning it. It's also very important to have manual approval gates for these production deployments. This goes without saying for any of the other processes, but making sure that there's really, really solid code review processes that at least at some point, some human is getting eyes on what's actually being updated in the production environment. Another thing you can do on top of IAC SAST is compliance benchmarking. So CloudSploit or SteamPipe are a great way to do this. You can run these scans as point in time on either pre-prod or staging environments to make sure that all these controls you're doing at the static level is actually being adhered to when you're deploying it to staging, provided you're trying to get your staging cluster as close to your production cluster as possible. And that's it. I think every single tool I mentioned there is actually orchestrated under the hood by Nullify. So Nullify is a security bot for your code base. Every time it sees you detect or change everything from Python to your NPM packages all the way to Terraform, we orchestrate the best in class and best loved open source developed tools under the hood, give you that feedback right away in your code base. It also means that we're a really big fan of all these open source projects, contributing back to them. And whether or not you choose to use Nullify, I highly recommend playing around with tools like Trivi, Bandit, Kubescape, and some of the other ones I mentioned as well. That's it. Really appreciate you guys taking the time. I know it's gotten a bit late, but thanks so much and look forward to keeping in touch. Oh, sorry, there was a question. Yeah.
I was interested in maybe because I've seen it in the real world, a lot of that instance where you mentioned people running Bitcoin miners or Monero miners, usually on people's clusters. What would your recommendation be in getting that? Granted, when I find it's usually because they allow like unauthenticated access, and that's why I think at the first place. But do you have does Nullify or any of these tools include like a container whitelist, for example, or something like that?
Yeah, I think where we kind of stop is pre-prods of DevSecOps, so as much of in the code base as possible. But yeah, if I were to kind of think about like admission controllers or more kind of runtime Kubernetes security, Aqua, Sysdig, there's plenty of good vendors out there. I think for that, like making sure whatever you choose is not really blowing out your compute costs. So some of those require you to deploy like a whole separate cluster. Although some of them, those agents can be like baked into your images. I think those are the best ones. So if you can have something that like you bake into your own container definition, That way you don't have to have like a sidecar container at runtime.
Or just some kind of fingerprint those two.
Exactly, yeah. And then you connect that to your logging, your ticketing, or whatever, and you can get notifications if there's stuff like, high compute resource. On the other side of it is you can just manage your costing like really, really well. They'll use like kube cost or open cost. Yeah, I think to your point, like with an attacker, first thing they probably do is like obfuscate logging. So having some like intrusion resilient process around like measuring both compute usage and cost would be helpful in detecting like data compute theft. Yeah.
Thanks.
Thanks for the question.
So can't we actually add I don't know if the source code scanner do that? Yeah. But what I was thinking, during the creation of the, basically, generation of the code for deployment I think that it makes sense to actually add resource quota and limits on the workloads as well to ensure that there is no, it does not utilize the required, more than the required memory or the CPU.
Yeah, dead correct. You can also
And also,
Yeah.
I just remembered one more thing, that you can actually use the signing of the images, so
Correct.
ensure and verify those images during the deployment, so that ensure that there is no modification or supply chain attack from the images during.
Yeah, 100% correct. Yeah, obviously the first one, nice and easy. If you're scanning your actual manifest files, you can make sure that best practices like compute or CPU limits on your pods are running or are configured. And then to your second point, that's something I actually omitted intentionally, just because I think it's a bit scary for a lot of people when they start talking about commit signing and image signing. We obviously do it, but yeah, definitely a really good point. So I talked about tagging your images, but ideally if you can use something like cosign and actually sign them either with the commit hash or make sure the commits themselves are signed, and then use host that like a cosigning registry or image signing registry somewhere, you can get really, really good provenance all the way from commit to build on what's actually your containers. That's a really good point. Sign your containers if you can.
Also verify them.
Yeah, sign and verify, exactly. Yeah, don't deploy. Yeah, don't deploy any containers to production that aren't actually signed and verified. Sure.
I have a question about Kubernetes.
Yeah.
I've used Podman and Docker before, and mainly Podman because everything runs in user space. I was wondering when I run my container on Kubernetes and I don't specify the root option, is it running in user space? How does it work?
I might get in trouble here, so anyone correct me, but I think it's running in kernel land. Like not actually 100% sure, but yeah, to the previous question, I reckon the best way to get confidence around like if you do want to run your containers as root is bake in some sort of like monitoring agent into your image to make sure that like nothing malicious is happening at runtime. If that's your concern with it running like outside of user land. That makes sense. Thanks.
I think this might extend what you were saying, but would any of this security analysis look at, like, say, the process tree at runtime? Like, if something pulled down its own program and started that, and it was something you never saw in the news, because it was able to exploit, say, HTTP or something like that.
Yeah,
How
yeah.
would this stack of things catch something like that?
Yeah, definitely. So yeah, as with Nullify, like we're partnering with some of those runtime vendors. So I mentioned some of them like Systy or Aqua or other ones. But I think the way that they work is that you define policies and those policies govern like which commands can be executed at runtime. So it blocks it, you can block it granular enough down to like the command. So to your point, like an exec, like someone execing into a pod in production, so that it gets stopped. Curl, so if you want to block like specific commands, you can do that. And then you can also block by egress as well. So like, to your point, like if it's some really dodgy looking endpoint, you can block anything based off that as well. but they have patterns usually, and then those patterns define like behavior patterns define whether or not something's malicious. Yeah.
And so other stuff might catch that anyway, so like, so the traffic monitoring, for example, might pop something like that.
Yeah, I think so. With the traffic monitor, with this, it's at the control plane layer. So yeah, if you're having like you may not have egress filtering at like the infrastructure layer, right? Like you may not have, so it's much easier to build that in like, and then if you want to relate to like the container logs, like the actual access logs or the application logs, you can do that. So yeah, it's definitely best to do that at the control plane layer where possible. Because if you're doing it at just like the infrastructure layer, like maybe a CrowdStrike or something, you're just going to get an influx of logs. It's going to be much harder to trace.
Yeah, sure.
Thanks. Any other questions or to go? Cool. Thanks so much. Appreciate it. Thanks, guys.
Thanks, John. Hey guys, do you guys mind to spend just 2 minutes to provide us the feedback? And we will capture your name and do the raffle. Okay. So don't forget to scan the QR code or just type the URL. So it's our feedback form, please. So we do need your help to provide us feedback for us to improve, to optimize in the future. So we do have some giveaways from Google. Actually, unfortunately, it wasn't delivered yet, but don't be disappointed. I got the swags from CNCF and also CloudCasa. Luckily, we already have these here. And for the one from Google, we allow you, agreed by Google, we're going to deliver, but only 2, okay? So if you choose to take any one of the swags here, that's all good. If you choose the one from Google, I haven't saw it yet. And you do have the option. We're going to deliver, but you need to give us the detail, okay? If you guys captured the QR code, the link here. So now we continue to the, where's my mouse? So now it's open mic time. And also if you guys don't mind, yeah, we typically, as a tradition, we take a group photo. So make it shorter, yeah, no more than 2 minutes. If you have anything to announce, or maybe you have any jobs, you're looking for jobs, whatever, this is a platform for everybody. Okay, before I hand it over to this gentleman, I do have a few stuff to talk about, to highlight first. So first of all, our next few meetups. So some of these are part of our K8SUG, Kubernetes user group. So tomorrow, actually, we're running the similar one in Singapore. So that's why I normally say K8SUG, the most active Kubernetes meetup. So we are definitely making it more than once every month. And our next one here in Singapore, it's coming, that's July 20th at the Red Hat. And also I listed here a few relevant meetups in Melbourne. So you don't have to take a screenshot, take a photo. I will share you the slide okay, anyway. And also, I got 2 job openings, not from me or from my company. Somebody reached me out by email. They sent me an email or via LinkedIn. So there is one hiring about a platform engineer from a Whisper, and also another role is a system engineer. It's one of the big four firms, according to the guy sending me the message. Yeah, if you are interested, feel free to let us know. I will connect you with the guy he's hiring. Okay. So with that, I'm going to pass to this gentleman to.
I just need to the text one show something. I want to show three domain names.
Okay.
Or type 3 domain names.
You want to type here or just use the browser?
They are empty domain names, so I need to text. One本.
Okay. Just give me. Yeah, I think. Yeah, you might have to type it here.
Oh,
Is that all right?
hello everyone. I have something very great to show you guys. There are 3 domain names I have registered, and they are matrixmmo.com, oasismmo.com, and quipmmo.com. So they are inspired by the Matrix movie, the Ready Player One movie, and the Tron movie. So the matrixmmo.com domain is on sale. I put it on the GoDaddy auction. You can check it out. And all of these are for sale. Maybe we can have an auction. They are very good domain names. As you can see, they are .com domain names.
Yeah, that's all.
Thank you.
Thanks, man. Anyway, anyone else want to say anything? Anyone else? Seriously, anyone else want to announce anything, or you have anything to share? Maybe you learn something new, or you want to share. Maybe you are aware of any conference or meetup is coming, or it could be you just want to introduce yourself.
I think everyone wants to wrap up.
Okay, I think it's time for.
Yeah.
You want to add anything? Yeah, go ahead.
Sorry, Notify's having a launch event in Sydney, so if anyone's in Sydney next month, come say hi. And also gonna have a Melbourne launch event as well, and speaking at a few other meetups Melbourne side. So keep your eyes peeled. Thank you.
Thanks, John.